Right, hello. This is one more example of what we did in class of solving a trig equation. So solve the equation sine 3 theta equals a half for theta, which is a real number, where theta is in radians, right? So this is how I want you to do radians. So in class, we just started with radians. Then it's got really messy. It's got really messy. So maybe we'll just convert them all to radians at the end. We'll see. But my range is between 0 and 2 pi. Remember, 2 pi is essentially 360. So what we can do is we can start with radians or we can convert them at the end. I think we actually might be better converting at the end. So let's start this off the way we usually do. So identify what region sine 3 theta is in. So it's positive a half. So sex and the city. So it is going to be in the first region and the second region. Gorge. Second part, find my reference angle. So sine my reference angle equals 3 theta. Oh, that's 3 theta, sorry, spoilers. Equals a half. My reference angle is equal to sine inverse a half. My reference angle is going to be equal to, I believe, 30 degrees. Let's double check that on my calculator. 0.5, I think it is 30. Yeah, gorge. Right, step 3. Right, calculate calculate my two angles to find the general solution for. So theta 180 minus theta 180 plus theta, and 360 minus theta in quadrant 4. So if we were working with radians from the jump, you would have to remember another one of these. You'd have to remember in first regions theta. This is pi minus theta. This is pi plus 1/8. This is pi plus theta. And this is 2 pi minus theta. But I think we're just better off maybe converting at the end. So I'm working in my first and second quadrant. So my first angle is going to be just my reference angle, which is 30. Then my second angle is going to be 180 minus theta, which is going to be 150. Okay, so that's my first 4 steps. My 5th step, now I write the general solution. So for sine and cosine, is going to, we add on n360, and I have 150 plus n360. Right? This is my general solutions. So my angle is actually equal to 3 theta. So it's going to be 3 theta is equal to 30 plus n360. And 3 theta equals 150 plus n360. I want to get theta. I want to get theta on its own. So I need to divide. So I'm going to look at my first equation here. I want to get theta on its own. So put that back down here. I want to get theta on its own. So I need to get rid of this 3. So I need to divide everything by 3. So I'm going to have here theta is going to be equal to 30 divided by 3, which is 10, plus n360. 360 divided by 3 is n120. That's my first equation. My second equation is going to be divide all by 3 theta. So I'm going to have theta is equal to 150 divided by 3, which is 50. And n360, which is n120. 360 divided by 3 is 120. And now what we do is now to set up my little table. So we were dealing with sine 3 theta. Again, as I said, the general rule of thumb is if this is like a 3, we're going to look at the first 3 rotations. Remember, we start with n is equal to 0. So 0, 1, 2. Right, so 0, 1, 2. So set up a little table here, I suppose. So my first equation, so my first set of rounds, my first set of values for theta. Then I have n on top here. So I have when n is equal to 0, n is equal to 1, and n is equal to 2. So n is equal to 0. So my first equation here, 10 plus n120. So 10 plus 0 1 times 120, which is going to be equal to 10. That's my first equation. Here, n is equal to 1. So 10 plus 1 times 120, which is going to be 130. Then n is equal to 2. 10 plus 2 times 120, which is going to be equal to 250 degrees. Sorry, you can't see that there. Now here for my second equation is 50 plus n120. So that is going to be 50 plus 0 times 120, which is just 50. Then I have 50 plus n times 120, which is 1 times 120, which is just 170. Then 50 plus 2 times 120, which is going to be 50 plus 240, which is 290. So my 6 solutions are 10, 130, 250, 50, 70, 290. Right, so let me just write these out. So I have 10, 50, 130, 170, 250, and 290. Right. And then the final thing, I have all my possible angles here. I need to convert to radians. And how do I convert to radians? I multiply by, all of these by, so I'm converting degrees to radians. So remember, 360 is equal to 2 pi. I want to get 1 degree on its own here. So it's going to be 1 degree is equal to 2 pi over 360, which is equal to pi over 180. So that's kind of my ratio I'm working with here. So I need to multiply everything here by pi over 180. So you just whip out your calculator. Here's my calculator here. I'm going to multiply every angle by pi over 180. So that's how we can convert degrees to radians. So we have 10 times pi over 180. So my first angle is going to be, so this is radians. So my first one's going to be 1/18 pi, or just pi over 18. My second one is going to be, so I'm looking at 50. Five pi over 18, or 5/18 pi, doesn't matter, wherever you choose. Next one. So next one's 130. So multiply 130 by pi. 13 over 18 pi. And 170. Hey there. 170, which is just 17 pi over 18. Then it's going to be 250. Which is 25 pi over 18, or just 25 over 18 pi. And if I had the last one, 290, which is 29 over 18 pi, right? Or 29 pi over 18, whatever you fancy. And there we are. So there's all my solutions there. And then we can check them with my calculator. So if I just go to my calculator now, make sure I put it in radians, because we want to check my solution in radians. So shift, setup, angle unit. We want to go to radians, we click 2. So I'm in radians now. So my original sum was, I believe, sine 3 theta equals a half. So sine 3 theta is equal to half. So hopefully now, when I put these in my calculator, so sine 3 times pi over 18, or 1/8 pi, or 1/18 pi, I should say. That's equal to a half. Gorgeous. Next is 5 pi over 18. A half. Gorgeous. 13 pi over 18. That should give me a half. Gorgeous. 17 pi over 18 is a half. 25 pi over 18 is equal to a half. 29 pi over 18 is equal to a half. So all of my solutions work, and that's it. And I hope this video was some help to you guys. And do your work in study hall. Bye.